Hello and welcome to this project video where we will execute the entire data engineering project from start to end, from extracting data, doing the transformation, and then loading the data and doing analysis on top of it. In this video, we will be using Azure Cloud. So we will be learning about many different services and we will understand the basics of Azure Cloud as we go. And we will be using Data Factory, Databricks, and we will learn how to write Spark code in Synapse Analytics and how to build a data lake and many more things. Let's get started. So in this video, we will take the Olympic dataset, which is available in Kaggle, and we will build end-to-end Azure data engineering project so that we can use major services which are available on Azure Cloud and try to build a sample data pipeline. We will copy the data and do some basic transformation and then load the data onto a target location. So this is the architecture diagram. As you can see, we have a data source which will be the Kaggle data file for the Tokyo Olympic or the 2021 Olympic. And then we have some data ingestion mechanism. So we will be using Data Factory for that. And and then we are going to store the raw data into Data Lake Gen 2, which is a type of data storage. And then we have some transformation. And so we will be using Apache Spark. Then we are storing the transformation block and the transformation data into again Data Lake Gen 2. And then we will be using some analytics using Azure Synapse Analytics. And then in the end, we will be creating some dashboard. We can use Power BI, Looker Studio, or Tableau. So let's try to understand the entire architecture diagram one by one so that we can get the understanding about each and every individual service. First, let's deep dive into the individual service. So the first service we have is the data source. Now, to understand this architecture diagram, you need to know the basics of ETL, extract, transform, and load. So, in extract, transform, load, or basically ETL, we basically extract data from multiple sources and then we apply some logic or transformation logic. And then the transformation logic can be anything such as cleaning the data, removing duplicate values, null values, or applying any business logic, and then we will load that data onto some target location. In this particular diagram or the architecture diagram, this all the services are built on Azure Cloud. Now let's look at our data set. So this is the data set we will be using, and we can directly download the data set from here if you have a Kaggle account, or you can just use the GitHub repository. And let's understand what type of files we have. So here in this, you can see there are various files. As you can see here, athletes, coaches, entries, gender, medals, teams, etc. Now, then after getting the data source, we will use something called Data Factory. Now, Data Factory is an integration service that you can build a data pipeline on, and you can connect multiple sources if you want to do some basic transformation. You can also do that. We have a lot of different functionalities available, and this is the service available on Azure that you can use to build a simple pipeline, or you can do some complex work if you want to do that. So this is about the data factory. Then we will be using Azure Data Factory to extract data from our data source, and which will be GitHub. And then we will load the data onto our data lake storage account. And so what basically is a storage account? A storage account, you can inside a storage account you can create containers where you can store the block files, or you can also create tables. There are multiple things available, but the overall goal of the data lake storage is to store the structured and unstructured data onto a storage. So that's what we will do. And then we will extract the raw data, and we will store the raw data as it is on our storage location, which will be the storage account. And inside that storage account, it will be a container. After that, what we want to do is some transformation code on top of this. So what we will do is we will get this raw data and we will write our code on Apache Spark on a Databricks environment and do some transformation. And then again, we will load our data onto transform data. So after cleaning the data and performing some basic operations or basic transformation, we will again load the data onto the data lake storage, and we will have the raw data stored, and then we will have the transformed data stored. Both of these datas will be stored into our data lake storage account. Once we have that, we can use analytics service called as Azure Synapse Analytics. So in this you can use multiple things. You can use a notebook, or you can use SQL functions to run the analytics query on top of it. So if you want to understand, let's say, who won the highest number of gold medals by country, or which player won the most number of gold medals, you can do that using the SQL queries. Also, at the end, you can build a dashboard using multiple tools such as Power BI, Locker Studio, or Tableau. So here is the overall understanding about the architecture. You have the data source available. We will use some integration service provided by Azure to build a simple pipeline. We will load that data onto the storage location. Then we will write some transformation block of code. Then again, we will store the transform data using Azure Synapse Analytics. And you can do some analysis on top of it. And then we can build a dashboard. So I hope you understand about this. And now we will try to understand each of the service in a little bit detail. And let's first understand what our data exactly is. So let's go to Kaggle. And here you can see this. Let's look at the details. And this will give us the details of this athlete's table. There are name, NOC, discipline, and it gives us the name of the athletes. First, let's say it's Norway, and the discipline will be discipline is the games they participate in, and there are total of 11,062 values, basically meaning that 11,062 athletes were in the Tokyo Olympics 2021. So now let's look at coaches. You can see the details. So there were total of 381 coaches, and the names and where they belonged and what discipline or what sport they coached. And so else we have teams. You can look at teams, like what some sports are played in teams. It's 3 by 3 basketball and stuff like that. Now you can easily download this data from Kaggle, and I will ask you to understand this data on your own. Take some time, like spend at least a minute or two on each of these details table, and take a look like what exactly is the schema, and how it is divided, and what that specific tables entail. Now that we you can understand the overview of the data we have, such as we have total of 5 files, and these will all be in a CSV format, and we will understand this data based on what we want to use, what we want as transformation, and how we want to sort our data, how we can clean the data. So we should have a basic understanding of what our data exactly is. So now let's understand the individual services that we will be using in our project. Let me wait. So these are the services we will be using. Okay, let's try to understand the Azure services. So we have multiple services available, and we already talked about in our architecture diagram. So the first one we have is Data Factory. So Data Factory is a data integration service that enables you to create, schedule, manage data pipelines for efficient data movement and transformation between various sources and destinations in Azure and beyond. So it is a service specifically designed to create a data file plan, and you can create a simple flow if you want to transform some data. You can also do that, and you can use a data factory to load the data onto any target location. It can be data lake, it can be data warehouse such as Snowflake or RDBMS. If you want to do that, you can do that using Data Factory. So this is what the overall idea behind the Data Factory is. The next we have is Data Lake Gen 2. This is the solution that combines capabilities of a data lake with the power of Azure Blob. Now, Azure Blob is basically the object storage where you store the data in the form of a file on Azure Blob, and it is considered an entire object. It is the same as Amazon S3 or Google Cloud Storage, where you cannot have the hierarchical manner of data storage. So inside the bucket, each and every file is considered an object, but when you use data lake, you have this power to turn it into a hierarchical file system, just like the file system we have on our local computer. Like you can have a folder inside a folder inside a folder, and you can create multiple folders, and then you can store your files. So this is what the data lake solution provides, and there are more functionalities provided on top of it. So you can go and check it. And this is what the core idea behind Azure Data Lake storage is, that it can handle the structured and unstructured data, and you can do your analysis on top of the existing file and run your SQL queries. Okay, so this is what Azure Lake Data Lake Gen 2 is. Then we have Azure Databricks. Now to understand this, let me explain you in a very simple manner. Okay, so we have Apache Spark, which is kind of like we use for transformation and data processing. So this is the open source framework for data processing. Then Databricks is basically the a kind of like software company that provides the Apache Spark solution. It provides a lot of different solution, and it's kind of like a managed service where you can write your Apache Spark, so you don't have to worry about managing your cluster and other things. It's kind of like an online platform where you get everything at one place. When you try to install Apache Spark in your, let's say, local PC, you have to do everything by yourself after you have downloaded it and installed it. Put in environmental variables, and then you can do that over here. It will be managed by the Databricks company, so you don't have to worry about all the other things. And they also provide us with more services on top of it, such as Delta Lake. So there are many different services that they provide, and it's kind of like a good solution, so that Azure kind of partnered with Databricks and integrated their entire services on Azure cloud. So It is called as short Databricks. And so Databricks is a unified analytics platform built on top of Apache Spark, designed to help data engineers and scientists to collaborate on big data processing and machine learning work. So it provides the tool for exploration processing, building machine learning models, and scalable environments. Okay, so let's go on to the next service. Next, we have Azure Synapse or Azure Synapse Analytics, and it is connected with data warehouse available on Azure Cloud, just like we have Google BigQuery and Amazon Redshift Snowflake database. Data warehouse. So this Azure Synapse Analytics available on Azure Cloud is so that it's a SQL database warehouse and cloud-based analytics service provided by Microsoft Azure. It combines big data warehousing into the single platform. You can also do a lot of things such as you can build a data transformation pipeline, you can write the Spark code. So this is a short overview of all the services available, and these individual services have some kind of meaning, some kind of overlap. So what I mean by it is inside Synapse Analytics, you can create the data factory workflows. So they have kind of like integrated all the services. So instead of using data factory differently or Azure data breaks differently, you can just use a single Synapse Analytics and do your entire work, and you can create a data factory pipeline inside Synapse Analytics, and you can also write Spark code inside Synapse Analytics, and you can also write SQL code. Remember that you can do the entire thing on Synapse Analytics, or you can do it on Databricks, or you can do it on Data Factory, right? You can use either individual services or you can do everything on Synapse Analytics. But in this tutorial diagram or in this tutorial, we will use individual services so that we can understand, like have a better understanding about each and every service. Hello and welcome. Now, in this part, we will finally start with the execution of our project. Before that, let's just understand the architecture diagram a little bit in detail. So, over here we have our data source. So, we will be using the Kaggle data source of the Tokyo Olympic 2021, and then we will copy the data from the data source to Azure Data Storage, and we will be using Data Factory for that. And so inside Data Factory, we will just build a simple pipeline where we will take the raw data and upload the data onto the data storage, which is the Data Lake Jet 2. Once we have our data available onto the raw data storage, then we will use and then we will be using Azure Databricks, and we will write some Python code, Python Spark code, and we will do some perform some basic transformation, and we want to just build a simple pipeline. So we will try to remove the duplicates, and we will drop some columns, rename it, and then later we will upload the transform data to the data lake storage. And so our initial pipeline will be where we will load our data and do some basic transformation, and then again we will load that data onto data lake, and then we will be using Synapse to understand our data, so we can easily write the query on top of these data and that we have transformed and extracted the insights from. And if you want to build a dashboard using, let's say, Power BI or Glucose Studio, we can do that as well. Now let's move on to our Azure portal. And we will be doing everything step by step. And the first thing you need is to go to Azure portal. And uh, so the first task we will be performing is to ingest our data to the external data. So as per the architecture diagram, we need two things, which is Data Factory to create the simple pipeline. And the second thing we need is Data Lake Gen 2, which is to store the raw data. So let's start by creating these two things first individually. So the first thing we need to do is let's go to the search bar and type storage. So to create a Azure Data Lake Gen 2, we first need a storage account. So you can just search for storage account or go to this hamburger option, and inside there you can get the storage accounts from here as well. Now let's create a storage account, and let's create a new resource group. Let's give it Tokyo Olympic and click on OK. This will create a new resource group for us, and let's now give the storage account name, and let's give again Tokyo Olympic. Uh, I can't use this, so Tokyo underscore Olympic name, can't use that. So let's give Olympic Tokyo 1122. Well, uh, storage account name is unique all over the Azure universe. So if the name you want to use is not available, you can use numbers like this in the end. Now let's select a region that's close to us. We can, and let's select Asia Pacific Central India. Now we do not want anything else. Let's just select, and let's just select next and scroll down. You will see a hierarchical namespace option, and make sure to check this. With this, you can use uh, the storage account or a storage as a namespace. So basically, you can create folders inside it and use them as repositories or directories like in our local computer. Now click on next. Now just click on review and create. So this will take some validation progress, and it will take a few seconds, and then we can just click on create. This will initialize our deployment and we can create our storage account. Let's wait for the deployment. It's currently in process. Now our storage account deployment is complete. Let's click on go to resource. This will take us to our storage account, and here you will see some basic information about the storage account. And on the left hand side, there are various tabs. You can see the activity log, and currently there will be nothing because it's just created a few minutes ago. And there are various different options, but we are not currently interested in all of those. So the one we are interested is in containers, and let's go to containers. And in here we will be creating a few containers. Let's click on create container. Now let's give a name to our container. The name we will be giving is Tokyo underscore Olympic underscore data, and it's not taking underscore, so let's just give hyphen. And this is the name we are giving. Click on, yeah, we do not want to name other settings. Click on create. Now inside, let's go inside the Tokyo Olympic data container. And here we will be creating a few directories. Let's click on add directory. The first directory we are creating is raw data. Here we will save all the raw data and let's create another directory and transform data. So here the data after transformation will be saved. Now the next step is to create an Azure Data Factory. So to do so, let's go to search bar and type Data Factory and go to these data factories and let's click on create. Now let's select our resource group we created. So search for Tokyo Olympic and we will be creating everything we need for this lab or this project in this resource group only. And now let's give a name to our data factory, Tokyo Olympic DF. This should look okay. It's already chosen and it doesn't take hyphens. Sorry, Tokyo Olympic Data Facto. This should work. Yep. Now let's select our region. Let's always select a region closer to you. Now click on next and we do not want to do this. Next, let's just click on review and create. And after a few validations, it will give us the option to create. Now let's click on create. This will create our data factory and inside the data factory, we will be performing our transformation and the functions we want to perform on the data, which is the Tokyo Olympic data. Now our deployment is complete. Let's just click on go to resource. And after scrolling down a bit, you will see Data Factory Studio and get the option to launch Studio. This is what we will be doing. And we do not need to worry about anything else. Let's just launch the Studio. This will take a few seconds. And here is our Data Factory Studio. Here we can perform various operations like ingesting data, orchestrating data, transforming data, configure SSIS, and various others. Now, the first thing we will be doing is copying the data from GitHub to our uh, storage account, which is, and let me show you that. So this is the Olympic Tokyo. So, and inside it, let's go to containers. So the first thing we will be doing is copying the data from GitHub to our raw data folder, and then we will perform some functions on it later. But let's do the first step. Let's go to our GitHub repository. Now this is my repository. You can create your own. And here we have all the 5 files we had in Kaggle in CSV format. Now let's go to Azure Data Factory Studio. And in this, we will be first creating the copy function or the copy activity to perform copy to our storage account from GitHub. Now inside our Data Factory Studio on the left hand pane, there are few options, author tab, and in here you can create the pipeline, the monitor tab, you can monitor your pipeline runs, trigger runs, data flow debug. In the manage, you can create some connections like linked service, integration runtimes, and various other options. You can also get your triggers here, and there is the learning center. Now we will go to author tab and inside here you can see currently there are no pipelines. So click on this three button to get the pipeline. Now we will be creating a new pipeline. Let's just name it. The name we will be giving is, let's say, data ingestion. Now let's close the properties tab and also let's move forward with our first activity. So here are various or most of all the activities present with the Azure Data Factory. Copy data, data flow with Synapse. You can create notebook with Databricks. You can create notebook, jar, Python, and with Data Lake Analytics, you can use USQL And with machine learning, you can use whatever machine learning provides with this machine learning batch execution. So what we will be doing is copying the data. So let's drag and drop copy data onto our activities pane. Now let's give it a name. Let's give it the name as, let's say, athletes, because the first file we will be copying from, and it's not this, copying from GitHub is athletes.csv. And let's go back. Now, let me drag this up. The first thing we will be doing is creating a sink. So we have to select a data set. Currently, there is none. Let's select. And because we are using GitHub to get our data, so the sink type will be HTTP, which is basically HTTP connection because our repository is public. And so let's select HTTP and click on continue. Select format, which is basically CSV. Continue. Let's give it a name. Again, let's give athletes, and let's select our link service. So we have not created a link service as of now. So let's just create one. Let's give it athletes HTTP. And so here is an option to get the base URL. How we can get it? Let's go to athletes.csv on our GitHub, and you can click on this raw button. And not this, I want it. I don't want to open it. I want it in a, wait a second. Now to get the raw data, we will be using some workaround because currently I don't know why it's not working. So let's just go to our data factory, and here it is. And inside, let's paste the basic raw URL, which is raw.githubusercontent.com. And in the end, we have this URL only, which is username slash directory, then main data athletes.csv. So let's paste it here. Make sure to delete this blob from here, otherwise this will not work. So this should, if you copy this and paste it in a new tab, it will give us the download option for athletes.csv. So like this, you can check for if this URL is correct. And let me copy it for future purposes. Now go to authentication. This will be the authentication. If you are using a private repository, you can go to basic and give your username password for GitHub repo, but because it is an open or public repository, we will be using just anonymous authentication. Now everything looks fine. Now click on create. This link service will be created, and we don't need to enter anything in relative URL. Make sure to check this option of first row as header, so Da- Data Factory will know to treat your first row of the CSV file that it gets will be the header or the schema. Now let's go to OK. This all is fine. You can preview the data. Let's see. And here you can see our data is here. We did not download anything. We did not load anything onto Data Factory, but we can see our data. This means our connection is working. Now let's create a sink. So what sink is the storage for the data that we copied from GitHub, so where it will store. And currently we do not have any sink, but let's create a sink. And the sink will definitely will be Data Lake Gen 2. And select it, continue, CSV, and let's give it a name, uh, athletes sink. And this doesn't work. It is underscore. Yep. Let's create a new linked service. Let's give it a name, athletes sync, and it doesn't contain that. Yep. Now authentication type account key. Let's select our subscription. Let's give the storage account name and install looks fine. Now what's missing? Made no changes. It's now working. Let's test our connection to the new linked service. Connection successful. Now click on create. This will create our linked service. Now we have to give the file path. So let's click on browse. If you had not selected the hierarchical namespace, you will be getting some error here. So let's go to Tokyo and we are creating a sync. So let's go to transform, no, raw data. So what we want to do is get data from GitHub to the raw data folder. And here now let's give it a name. It athletes.csv was athletes, right? Yep, athletes.csv and import schema, none. First row as header, yes. And now click on OK. And everything else looks fine. Now let's try to run our copy activity. Go click on this blank space and click on debug. So what this will do is copy our athletes.csv file from GitHub and paste it into our raw data folder. It will take a few seconds or even a minute to do so, and then we will be able to see the athletes.csv file inside our raw data folder. Let's refresh, and our pipeline succeeded. Let's go to our raw data folder, and here you can see athletes.csv is present, and now we have to do the same for all of the other files. So let's drag and copy activity. Let's give it a name. What the next file was coaches.csv. I will just, sorry, just coaches is fine. And source, select dataset. Now click on new. It was HTTP. Continue. CSV. Continue. Linked service. New. And here we will give, let's say, coaches underscore HTTP. Let's give the base URL. And we copied the athletes URL. So let's just change from athletes to the exact name of the file. And here it is, coaches.csv. Let's just copy it and paste it in the end. And authentication type anonymous. And let's test connection before we proceed. Now click on create. No need for relative URL. Rest all is fine. Okay. And we forgot to give a name. Let's just give the name. Why was it? Okay, here. And we also give coaches. And just coaches is fine. Now let's close it. Close and discard changes. Oh, sorry. Let me do it again. Accidentally deleted it. Create new. Okay, we have our linked service. So let's just select it because we did not delete the linked service. Okay, our source is done. Now sync. And we will create a new sync. And sync is gens2 CSV. And let's give it coaches. Uh, Give the name as coaching sync, and we do not need to create a new linked service because link service remains same. I mistakenly give it the name as athlete sync, but don't worry about it. Let's just give the file path Tokyo Olympic data, raw data. Okay, and let's give it coaches.csv and import schema none. Okay, and this looks fine. General looks fine. Now we can run this. Let's also give the on completion. So what this will do is when this athletes one is completed, then only the coaches will run. Let's test it. To test, let's click on debug. This will run our pipeline. And so what this will do is copy the athletes.csv from GitHub, paste it in the raw data folder, and then after completion of the athlete's activity, then it will go back to GitHub and copy the coaches.csv and paste it again in the raw data. Now let's refresh our debug run successfully. We can also get the output and let's close it. Let's also check inside the container and here you can see athletes.csv, coaches.csv. Now we just have to do it 3 more times. Let's do here. I will fast forward this. The next thing was entries gender. Let's copy and I can't do it. Source. Now add new HTTP here, here, CSV, and let's give it a name. Link service. This is a source. We have to create a new linked service. Let's give it a name. Entries, and let's also give the base URL. So this was our base URL, and in the end, let's paste. Okay, and in the end, we will be pasting entries gender.csv, authentication type anonymous, and rest all is fine. Let's test the connection before we proceed. Our connection successful. Relative URL empty. Now, okay, sync, new sync, and sync is gen2, CSV, give it a name, trees, select the linked service, let's give it the path, raw data, okay, now let's give it entries, gender.csv, none, okay, and let's preview the data from source, and here you can see it's correct, and let's drop another activity. We can move it here and on this. Let's do this and let's select this and let's rename what was the next medals.csv. So just give it medals source new http csv medals one and link service new medals base URL. Let's copy this and let's select medals.csv and authentication type as anonymous And let's test connection before we proceed. Connect. Relative URL empty. Import schema none. Let's preview our data. And here you can see medals.csv. Let's close this. Create sync. New sync. Data lake. Continue. CSV. Continue. Give it medals. And let's select the link service. Let's select the file path for the folder path, raw data, and okay, let's give medals.csv. And let me tell you one thing, if you do not give this medals.csv, what it will do is it will create all the folders here like username slash Tokyo Olympic data slash blob slash main slash data, and then your CSV file will be there, which we do not need because every slash here is treated as a different directory. So you will get multiple directories here. As you can see, a slash is Tokyo Olympic, then raw data, and then medals.csv. So should give the name, otherwise you will get a lot of folders unnecessarily. And now click on OK. This is done. Uh, how many we have? Four right now. Let's create the fifth one. And on completion, the fifth file name is Teams. Let's say this Teams source new HTTP CSV continue. Let's give it Teams, select link service, create new link service, give this Teams base URL, and let's change the name Teams.csv authentication type as anonymous, and let's test connection before we create. Rest all is fine. Let's preview our data. So here you can see Teams, and now sync, create new sync type gen2, continue, delimited text. Let's give it Teams and select link service. Now path to the place where we want to store raw data, and okay, now give teams.csv, import schema none, okay, and everything looks fine. Now the final step for this part is to run this pipeline. So what this will do is copy athletes.csv from GitHub and then paste it in our raw data folder. And on completion, go to coaches, do the same, go to entries gender, do the same, go to medals, do the same, go to teams, do the same. Now let's run this. Click on debug, and this will take a few minutes. So it will give us first athletes.csv athletes copy activity will perform, and then coaches, then entries gender, it will give us, you can see athletes succeeded. Now it's working on coaches. Let's wait for it, and currently it's in progress. It took around 13 seconds for the first one. Let's see, coaches also completed in 12 seconds, and now it's working on entries gender. Let's refresh. And entries gender also completed successfully. Currently working on medals. Refresh. And is still under progress in 10 seconds. So it's taking about 12 to 13 seconds for each copy activity.
And copy activity means copying the data from GitHub or copying the CSV file from GitHub and pasting it to our Azure Blob Data Lake storage. And all of the activities are now succeeded. Now let's go to the Tokyo Olympic container, and here you can see all the five CSV files are present, and this means our copy activities were successful. You can place it here, zoom in, zoom out, make it look a little prettier, and that's fine. Now let's see you in the next path where we will transform our data and use Databricks to do that. Thank you. Hello and welcome back. In this part of the video, we will perform some operations or analytics on our data that we copied from GitHub. Basically, the Tokyo Olympic data, and here is our data. So these files are the one we copied from GitHub, and now we want to perform some operations on it. So what we will do is use Databricks for it. So before that, let me just give you a review of what we did in the previous part of the video. So what we did was we copied data from GitHub. So we created some copy activities in the side of pipeline. And in each copy activity, we created a source and a sink. The source was the GitHub repository, and we used a HTTP type source to get data from GitHub repository to our container, which was named raw data. Sorry, the container name was Tokyo Olympic, and inside it was folder named raw data. So we created a source and a sink. Sink basically what the container name is, and we completed this or we performed this activity total of 5 times because there was a total of 5 files in our GitHub repository, and we performed it on completion. So we created each pipeline activity and attached it from to the previous one with the on completion command. So after completion of the first one, then it will move on to the second one, then third, then fourth, then fifth, and finally give us the output as like this. So first athletes, then coaches, then entries, gender, then medals, then teams, and this will copy all our CSV files from GitHub to the raw data folder. Now what we want to do is create a Databricks. So open your Azure portal and go to search bar, and let's search for Databricks. And here is our Azure Databricks. Let's create it. So inside Databricks, we will be performing all the functions or the transformations or the analytics we want to perform. Let's select our, sorry, let's select our resource group, which was Tokyo Olympic, and now give a workspace name. Let's give Tokyo Olymp, spelling is wrong, Olympic hyphen, let's give Databricks. It should work. Central India, pricing premium. Now we do not need to perform any other thing in it. Let's just click on review and create, and this will perform validation, create, and this will submit our deployment and will take around a few minutes to create the Databricks workspace. And then we will perform some few transformations and basic analytics function on it. So let's wait for the deployment to complete. So what we have performed till now is get data from our data source, then ingested that data to Data Factory, and then copied our data from the data source to the Data Lake Gen 2, which was the container that we created and which was named Tokyo Olympic. Now we will be performing transformation on our data using Azure Databricks. So let's check our deployment, and our deployment is complete. Now click on go to resource to go to the deployment resource or the deployed resource. These are the basic functionalities or the essential information about the resource that we just created, which is Azure Databricks service. and you can take a look at it. And now what we are interested in right now is to launch the workspace. Let's launch the Databricks workspace. It will log in to our Databricks using the Azure credentials, and this is the basic UI of the Databricks workspace. And you can click on plus new to start your journey. This will give you option to create a notebook or dashboard. Here is the workspace. We can create multiple workspace, recents, and catalogs, and workflows, and compute. Compute is basically the compute engine that we will be using to perform the transformation or the analytics we want to perform. So the first step here is to create a compute engine. So let's click on create compute, and let's select the policy as unrestricted single user. Let's select single node because we do not want to waste our resources. And multi-node will cost more, basically what we are doing. And the standard, everything is fine. Terminate after 120 minutes of inactivity. You can uncheck this if you might be using it for a longer duration or might take a break or something. So let's click on create compute. This will create our compute for the actual transformation or the functions or the queries we want to run on our data. And there are various other multiple options like SQL editor, Genie, and data engines, data engineering jobs, machine learning jobs, and everything. And what we'll be doing is creating a new work notebook. So let's click on new and then click on notebook. And in the meantime, our compute is running. So compute is being created. Let's just wait for it. Our compute is now up. Let's select it and you can see it's connected. Now, what we want to do first is to create a connection between Databricks, which is where we perform our transformation, and between the actual data, so basically the storage container. So what we will doing is creating something like a mount, like how we mount a hard drive or an SSD to our computer. We will be mounting the storage account to our Databricks. Before that, let's just rename this, give Tokyo Olympic transform, should be good. Now what we will be doing for that is going back to Microsoft Azure, and let's open it in a new tab. And we will be creating something called an app registration. So let's just search for app registrations. So what will this be is a simple registration to get the data from our data lake storage, which is the Tokyo Olympic data, and give it to Azure Data Factory, which will be the Azure Databricks, sorry. And this will work in the backend to transfer the data from a container to the Databricks. So what we will do is just click on new registration and let's just give it any name and make it say register one, and no need to select anything else, just click on register. This will give us a few IDs, so what we need to copy, and let's just copy this. The first we need to copy is client ID or the application client ID. Let's just open a notepad and paste it there. So client ID, let's paste it. Now in the next thing we want to copy is this directory tenant ID. Let's copy this as well and let's paste it. Now what we want to do is create secrets like how we created in AWS for Terraform, and we will be creating a secret. So click on manage and expand manage, and now we will go to certificates and secrets. Now click on new client secret and let's give it a name. Uh, let's give Tokyo. and expiry date, whatever you want. If you want to expire it in 6 months, 6 months is fine. And we got our secrets here. Now let's copy and save it in a notepad, secret value, and the second thing is secret ID, and let's paste it. It's fine. Now, what we will do is inside the Databricks, we will finally perform the connection, and let me just copy the code. Now, this is the code to create the authentication. Let's get our client ID, secret ID, and tenant ID for here. Let's open Notepad. Let's first copy client ID and paste your client ID on this one, Azure account dot authentication to client ID. Now, in the secret, let's copy the secret ID as well. Sorry, this. Now, in secret key, we will be copying the secret value. The value has identification. It starts with a letter and a tilde. So remember that. Now, secret I value, and in here in the endpoint, we will give the tenant ID. Let me just copy the tenant ID as well. And the tenant ID. Now we will be able to connect our storage account or the data lake storage to Databricks. Let's finally mount the data lake storage, and we will be using the code. Sorry. Now this is the code to mount, and what we need to provide some information here. The first thing we want to provide is the container name. So let's go to the container. This is the container, and let's just copy the name Tokyo-Olympic-data. Let's go to Databricks and let's paste it here. Now we want to give the storage account name. So this is our storage account Olympic Tokyo 1122. Go to here and let's give. This is a little bit complicated, no need to worry. Now we just need to give a mount point name. Let's give Tokyo. The Tokyo is fine. And here I have provided what you need to give. So container name at the rate storage account name, then DFS core windows.net. Now let's run this code. Let me take a look again. Looks fine. So this will create our connection with Azure Data Lake storage. Let me zoom out so that you can properly see. And this will uh, create our connection with the data lake storage for the next time we want to get some data from the data lake storage. So it runs as true. This means that our data connection was perfect and there was no issue. And even if you get an error, there would be an error with you might have missed or replaced the client ID or secret or something else. Now, the next thing we want to do is get our we will check the data if it is present or if our connection is actually successful or is it just giving us the true value. So let's type percentage %fs. So now we are accessing the file system and let's list the files inside. So let's give and we just have to copy the mount point, copy, paste. Let's run this. And this should give us the raw data and what the other folder was. And there seems to be an error. permission mismatch. And why we are getting is error because what we were trying to do is we created app registration and we were trying to use that app registration to get data from the data lake storage to our Databricks. And so what we did was we did not explicitly provide that app to get data from data lake to our Databricks. So what we will do is go to this and we will go to our Tokyo Olympic container and here we will provide an IAM access to our Databricks or the application to be specific to get uh, read, write, or delete the data from uh, what do you call it container. So let's click on add and add role assignment. And here we will be selecting uh, an IAM role. Let me just search for it. And yes, so we will be selecting this storage blob data contributor. So this allows for read, write, and delete access to Azure storage blob containers and data. So we will be providing this access to our app that we created. Now click on next and click on select members. Here we will just select our app that we created that was named register. Yep, register one was the name and let's select and nothing else. Click on review and assign. So what this will do is explicitly give the register one application that we created access to the Tokyo Olympic data container to read, write, or delete data. And let's click on review and assign. And let's wait for it to complete its. And our role was added. Now we can go back to Databricks and run this command or this query. This will, let's just wait for a few minutes. Uh, After a few minutes, it will run properly because IAM takes some time to create the profile and role. Let's just wait. About after a minute, it was able to run. Now you can see the raw data folder and the transform data folder present here. And so what we did was basically gave our Tokyo Olympic data, created an IAM role so that our application that we created was able to explicitly read, write, or modify the data inside the Tokyo Olympic. And then we used it inside our mount Databricks to get the storage structure or the structure of the Tokyo Olympic data container. Now let's move on to the next cell. Now in the next cell, what we will do is we will create a simple Spark session and we will try to look for the data of the athletes.csv. So let's give athletes equals to spark dot read dot and we will give format and now of course CSV and dot we can give this option header true, but let me just show you what before that first load and and let's just delete this. We do not want to show it right now. And let's run this. This will create a Spark session and there was some error. There was no athlete events. I forgot to change the name. And inside raw underscore data slash athletes, it was athletes. Let me just check. And here, okay, overview, raw data. Here you can see athletes.csv. So now let's run it. And it's done. Now let me show you what it did. Athletes.show. And here you can see our athletes. Wait a second. Our athletes table is here, but currently it's not reading the person name, country, and discipline as the schema. So what we will do is add an option to it. The option we can add here as well. So let's give header equals to true and infer schema equals to true. So what this will do, header equals to true will treat the first row of the athletes.csv file as the header, and infer schema will try to guess the type of the data that is present inside that column. So let's run it. And now it ran successfully. Let me, okay. Now as you can see, the person name, country, and discipline is now as the schema, and you can see person name string, country string, discipline string. So this was basically all string values. So let's move on to another cell and try to do the same for any other which have either integer values or boolean values. So let me paste it. Let's give here, let's check which one could have, I guess medals should have integer values. So let's give medals, and let's change here as well. Let's first delete this and run without it. And let's also give medals.show. Let's run this. And here you can see the schema is wrong, and you can see it gave everything as string. Now let's try to use infer schema and header equals to true. Let's run this again, and it's done. Here you can see it changed. So rank is integer, team country is string, gold integer, silver integer, total integer, and our schema is also correct. United States won 39 gold, People's Republic of China won 38 gold. Now let's do the same for all of them to show you the schema that we can read it. I will do it a little quickly. Uh, coaches and coaches.show. Let's run. And here you can see the coaches for each team and the schema as well. Everything is string. Yes, it is string. And let's do the same for what was the last one? Athletes done, coaches done, medals done. So teams and entries gender. Let's go teams, teams, teams. Let's run it. Here you can see the teams and the data type for the data frame. Now let's do it again for gender. This sound a little weird, so gen is fine. And let's copy the file name entries gender.csv, and here you can see the total number of females, total number of males in that category, and total is basically plus. Now on to the next cell. So instead of giving header equals to true and infer schema equals to true inside load, you can give it as an option, and this will produce the same result. So let me run it, and as you can see it's the same result and in schema as well. Now let's move on to the next cell. Now we will perform some basic transformation on the data. So let's first, and yeah, teams. Now let's say are not using infer schema to get the actual schema, so that our uh, Spark engine is not giving us the proper result. So here it is giving female as string and male as string, even though it is number. So what we can do is transform this data type from the data frame. So let's move on to the next cell. Now the schema, let's say infer schema didn't work, and the schema for gen, which is the genders file, is currently female string, male string. So what we can do is transform this schema to the integer type. So what we will do is gen equals to gen with column, and the column name is female, and cast, we will casting the string type to the integer type, and we are doing this the same for male and total. So currently it will give an error because we have not imported this column from PySpark. So let me run it before that as well. As you can see, column is not defined. So what we can do is go to the top, and here you can see, let's add one more, and let's import column and import the integer type. Let's run this. Now, if we scroll down, the code will not be under a red underline. So let's run this. Now, this time it will give or change our schema data type from string to integer. Now let's print the schema again, and we don't need to, we already did. So now let's move on to the next cell. Now let's say we want to perform some functions on our data, which will be, let's say, we want to get which teams got the most amount of gold medals. Let me, and here is the query. So what will this do is create a Spark variable named to top gold medal countries and order it by gold and ascending by false, and it will display only the team country and gold columns and show. Let's run this query. So there was some issue. Column variable function team country can be resolved. Now, so there was some error due to the issue that we were selecting the columns before even running the query first. So now let's run the query, and this will give us the ascending order, uh, so basically descending order of the total number of gold medals won by each country, with the United States of America at top, closely followed by People's Republic of China. Now let's only print the team country and the number of gold medals they won. Let's run this. And there seem to be some issue. So the issue was because our column name was team country, not team underscore country. So let's try to run this now. And here it is. As you can see, our columns are now properly displayed with the team country and gold, just team country and gold. Now let's perform some other transformations. Now let's perform the transformation to calculate the average number of entries by gender for each discipline. I have written the query. Now let's just run it. So here you can see uh, entries by gender. So 3 by 3 basketball for 32 female, 32 male, and average female percentages, or basically out of 1. Now you can perform any number of transformation or functions on this data set, whatever you deem to get the result as. You can also perform some ML operations like statistical analysis, t-test, p-test, and others. The sky is the limit basically. You can do whatever data transformation or data analysis you want to perform on this Databricks. And that's all for this project. Thank you so much.